Now, why don't I do this just so because we have an hour left here. Why don't I talk about the homework assignment first? And then I'm going to start introducing you to some things that'll help you with that homework assignment. But I'll then be able to reference kind of some, maybe some things to consider when you're writing the assignment. That makes sense? Um, so the assignment is this guy right here. I gave you a link to a so a Wikipedia for the game of blackjack. All right. So blackjack is a card game. So it's let's get to hold on a second. Here, I got to update that link real quick because they did change it. Oh, no, they didn't change it. I just gave you I copied the wrong link. It's the correct link. All right, so blackjack's a card game. So we're all familiar with these, normal playing cards. So the 2 of clubs, the 3 of clubs, those guys. Okay. So blackjack is a game that's played with those cards. Okay, and the goal in blackjack, and you can find, you can go and do a search, and you can play blackjack online. There's plenty of sites there. If you want to lose real money, you can go down to the casino downtown and go and lose real money playing blackjack. Okay, but the idea is that with blackjack, you have the 52 cards in the deck, right? All right, and 2 cards are dealt to you. Now, depending on the different games of blackjack, sometimes 1 card is dealt face down, another one's dealt face up. We're not dealing with any of the weird little crap. Okay, you get 2 cards. All right, your goal in blackjack is for all the cards that end up in your hand to get as close to 21, the score of 21, without exceeding it. That's your goal. All right. So if you're initially given a 2 of clubs and a 3 of hearts, you add the 3 plus a 2 together, that's a 5. Okay. Now, you can choose to say, I'm done. I'm not playing anymore. Okay. You probably are not going to win with a 5. Because chances are one of the other players is going to get closer to 21 than a 5. All right. But let's say you were at a 16. Now the idea is you might say, hit me, which says I want another card. And it could be that next card takes you over 21, which means you lose. All right, can't go over 21. All right, but now if you have a 16 and you pull a 4, now you're at a 20. You probably want to stop, right? You can actually win from a 20 with an ace, and I'll talk about that in a second. But the point is that the goal is you start with 2 cards, so you have to have at least 2 cards, but you could ask for more cards until your score exceeds 21. Exceeds. Yeah, that's when you've lost if you get a 22 or higher. You can't ask for more cards if you've already lost. All right. Your goal is the ideal goal is exactly 21. Or as close to it as you can without going over it. All right. Yeah, and then it's again. So if you and I are playing, and I've said, okay, I'm good, and my cards add up to an 18, and you said you're good, and your cards add up to a 17, I win. Even though none of us got to 21, I'm closer than you were. That makes sense? Okay. But if I'm at a 5 and you're at a 23, I still win. Okay, because you can't go over 21. Okay, 5 is closer to 21 than a 23 is because he went over. Over is automatic loser. Make sense? All right. The one caveat in blackjack is how the ace works.
What is the 1 and 10?
1 or a 11.
Yeah.
1 or an 11. All right. So in blackjack, all of the numbered cards count for their number. So a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, and a 10 all count as that number. Okay? All the face cards, the jack, the queen, the king, all of those guys count as 10s. They're always a 10. Okay? But now the ace can be either a 1 or an 11. So for example, this hand they're showing right here is blackjack. This is the blackjack hand. So you have a 10. This could also be a king or a queen. That's also got a value of 10. And an 11. That gives you blackjack. That makes sense? Now, you could also get blackjack with a king, a queen, and an ace. Because a king is a 10, a queen is a 10, and an ace can be a 1. Okay? An ace is allowed to be a 1. So when you're calculating the score for your hand in blackjack, you're going to be potentially, if you have an ace or more than one ace, potentially having different numbers that you might go with. Does that make sense? Ultimately, when you say you're done, you're going to figure out what is the maximum value of your hand that does not exceed 21. When the user finally says, look, I'm done. Then you'll calculate what your maximum value is. Okay. So, questions about blackjack in general. We have a pretty good idea of how it works. Okay, and there's plenty of games online. You can play blackjack for free and not lose real money. Okay, you can get it for your phones. There's blackjack games for your phones. So if we go ahead and design blackjack a little bit. So I'm going to help you think about blackjack in terms of objects. Okay? So we've kind of started off with tic-tac-toe and Connect 4, and we've done some objects with that. Well, now we're kind of stepping it up a level and saying, okay, well, now we want to really think about the object-oriented aspect of this. Because if we're sitting at the card table, sitting at a blackjack table, we have various objects. We have players, we have cards, we have decks of cards, right? You have hands, which is like, so if I'm a player, I have a hand of cards. So I have at least 2, if not more, cards in my hand. My hand has a value. That hand came from cards that were removed from the deck. Does that kind of make sense? Okay, so all these things go into that. So we have a lot of different objects. So if we think about blackjack, let's think about the objects that are involved. Okay? So we have a dealer. Right? Now a dealer is also a player. He's just like me, where he can play blackjack, right? Now I just want to review something real quick on the assignment. Okay, good. This is the easier version of this. I mean, it's still impossible, but it's the easier version of impossible. All right. So in this, you're not actually playing against the dealer. All right. The dealer's job is to deal you cards and take orders from you. Okay, so in our game that we're designing here, I'm a player. Okay, so we have a dealer, we have a player. The player is us. Right? Okay. The dealer does what? He deals cards. So the dealer is going to deal me 2 cards from the deck. The dealer would have a deck. So if you think about if you walk into a casino, there's going to be somebody sitting at a table who's going to be running that game, right? You walk up to him, and the dealer's probably an actual person. And in his hand, he's going to be holding a deck. And what's a deck? A deck is a collection of cards. So he's going to do the whole shuffle thing, right? Dealers shuffle the deck of cards. We've seen the crazy... All right, so we have a dealer, we have a deck, we have a card. All right, so the dealer takes the deck. So this is how we're thinking about things as objects, right? The dealer takes the deck of cards, shuffles the deck of cards, he deals 2 cards to the player. The player puts those cards into his hand. Okay, so I have a little hand of cards here. I'm peeking at them. And then I say to the dealer, I want more cards. So the dealer hands you another card. You put that into your hand. Then you ask your hand, what's my maximum value? Have I gone over 21? Yes, no, and we can rely on the player, and we don't have to automate it for them. The player can choose whether or not they want to get another card or not, but your program should be able to determine the maximum value of a hand. Okay? So it won't let them take another card if they've already gone over 21. And really, it's the minimum value of the hand is what you're looking for. Because you could have a hand that is 25, and at the same time, it's also a 14, right? If it was a 1 instead of an 11. So a 14 would be allowed to keep going. A 25 would not. Make sense? All right. So, you want to prevent them from doing things they're not allowed to do, but you don't have to do stuff like ask the player, what do you want your hand to be worth? Because that's going to change every single time you get a new card. So we can rely on the actual player to be able to look at their cards and say, okay, well, this is a 17. All right. And then they can say, I want another card or I don't. If the minimum value of their hand is bust, if it's over 21, excuse me, if it's over 21, then we're going to say you lost. Game's over.
So the program should know the deck of cards and what players have.
But we only have one player in this game. We're not competing against anybody. We're just trying to get as close to 21 as we possibly can. So this is the easier version. We don't have 20 people sitting in front of us. We basically are just sitting here and saying, look, I'm going to try to get close to 21. Because in a real casino, you might play against the dealer. In this case, the dealer's not even playing. Just a player. We're doing the blackjack mechanics. So we got one player. The dealer hands him some cards. He has his at least 2 cards. And then he can optionally add more cards to his hand. All right, so if we kind of flesh these out, what's a dealer? A dealer has a deck of cards and can deal cards to a player.
Question I have is the program knows the deck of cards and what cards the player.
We're going to have to write that.
Okay.
Yeah, we're going to have to write all those things. So we're designing, we're designing it here, and then I'll help you a little bit. I'll write a little bit of it. Okay, and the reason is because I don't know how to write this, so I'll have to go and study it and memorize it for next class so I can write it live in front of you. Right? That's what I do before every class. I go and I have to memorize all those lines of code. And just like people in plays, like when they do, isn't that what they do in plays? They have to memorize their lines. That's what I do before every class. I memorize the entire program. Huh? I don't think you can just memorize. Yeah, if you're memorizing large swaths of lines of code, you're probably programming wrong. You don't want to do that. It's a problem-solving type thing. All right, so the dealer has a deck, and he knows how to hand cards off that deck to the player. He also... So he can shuffle the deck and deal cards to a player. So that's what a dealer can do. All right, if we're talking about it here at the high level. What's a deck? It's a collection of 52 cards. That's what a deck is. Okay? What's a card? A card has a display, let's call it a display name and a value. So like king of, and also a suit. Display name, suit, and value. So you might have king of clubs. The display name might be K. The suit would be clubs. The value would be 10. That make sense? Okay, but you'll have to treat the ace as a special case because the ace can be either 1 or 11 depending on the situation. So you'll have to figure out how to treat him as a special case. But that's what a card is. So a card's a pretty simple object, right? It's got a name, it's got a suit, and it's got a value. Then what's a player? A player, this is us. So we're going to be asking ourselves, do we want another card? If we do, then we're going to tell the dealer, give me another card. And the dealer's then going to hand us another card off the top of the deck. All right. So the player is us. It's the interface with us to show us the contents of our hand and ask if we want more cards. What's a hand? It's a collection of 2 or more cards that can report on its value, something like that. All right. So at a high level, these are kind of the players that are the objects that are going to be involved in this. A lot of graphical programming, like learning programming tools, they think of the reason I mentioned a play a little bit ago, they think of an application like this as being kind of like a play, a scene in a play. Okay, so we walk into the play called Blackjack, and the scene in front of us, we have certain actors up on stage, right? We have a dealer up on stage, and then we got the really little short guy who's playing the deck, right? He's the deck of cards, and then we got like 52 really, really, really short guys. They're playing individual cards, all right? So these are the actors that ultimately make up the scene, and then they all have to work together to play out the game of blackjack. Okay. So at the high level, these are the actors involved in blackjack, at least the ones that seem obvious to be involved. So now what we want to do is, in our next little bit, is we'd like to figure out how to represent a card and how to represent a deck of cards. All right. And if I decide I'm going to be nice, I might even help you shuffle the deck of cards. Okay. That's only if I can recall that code I memorized to shuffle the deck of cards. All right. So let's go back here. Let's kill off the stuff. And I'm going to go ahead and I'm going to create a card object. So we'll start off with a card object. So before we can have a deck of cards, we need to have a card. All right. So we're going to have a card object. All right. And we decided that a card is going to have a display name, maybe it's display name, a display suit, and a value. Okay. So we'll say private string. Oh my gosh. See this keyboard. Display name, private string display suit. Is it suit like that or has it got an E on it? We'll assume I'm right. And then private int value. Okay. Now, when we build a card, that's going to be our constructor. So the name of the constructor matches the name of the class, case sensitive and all. We're going to need a display name, a display suit, and a value. So we need 3 pieces of information to build a card. So for example, if we were building the king of clubs, we would pass this guy probably a K for king, maybe just the word clubs for, since we don't have pictures here, word clubs for suit. Because what we have diamonds, hearts, clubs, spades. So actually you could just use the letter. That would be okay, right? All right, so we can pass it a C for the suit. So actually maybe with that in mind, no, we do need them as strings. And then the value will be the integer value. So for king of clubs, it's going to be a value of 10. Okay? So this guy's going to take in a string display name. a string display suit and an int value. And we'll go ahead and set display name equal to display name. This dot display suit equal to display suit. I really think it's the E, but whatever. This dot value is equal to value. All right, so we'll set up those guys there. Okay. Now, let's also teach a card how to display itself. So a card can kind of say, this is who I am. Okay. So we'll go ahead and we're going to say public void display. And this guy will say system.out.println. And let's go ahead and say display name followed by the word of followed by display suit. We'll forget about the value for right now. Okay, so we want to say king of clubs, that type of thing, right? So we're going to say this dot display name concatenated with a space followed by a space concatenated with this dot display suit. All right, so that's how a card displays itself. Make sense? Okay. Now that we have a generic card, we can test this real quick. Let's go out here to our driver and we'll say card C is equal to new card. And we'll give this, we'll say king of clubs. And we have to give it a value even though we're not displaying the value. And then we'll go ahead and say C.display. And we'll run this and we should get K of C. Make sense? Okay, and if you wanted to say king of clubs, you can do that as well. You can spell it all out. Doesn't really matter. Okay. Now we need a deck. Let's come in here. We're going to create a new class. This guy is going to be a deck. Now, a deck is a collection of cards. How many cards? 52. We know exactly how many cards we need, right? Do we have any sort of construct that we've learned about that could hold exactly a certain number of a certain type? Learned about arrays, right? I can create an array of card objects and say he's built for holding 52 of those dudes, right? All right. So we're going to go ahead, we're going to have a private card array, call this guy the cards. Then we'll have a public deck, the constructor for this guy, and we'll say this dot the cards is equal to a new card array of size 52. Defining a card array is no different than defining an integer array. Integer arrays are built for holding ints. Char arrays are built for holding chars. String arrays are built for holding strings. Card arrays are built for holding cards. And what's a card? That's the dude we just built. That make sense? All right. So now we need to go ahead and fill this deck. Because you say it's, what we've built right now is we've got a collection capable of holding 52 cards. We have 0 cards currently in that collection. Right? So you got the box of cards that's currently empty. Okay. It's the exact thickness box of cards we need to hold exactly 52 cards. But we currently have 0 cards inside of this box. We'd probably like to put some cards in here before we just start shuffling, right? So now I need to fill in this box of cards. What do you think? Do I write 52 individual lines and say the cards at bucket 0 is equal to new cards 2 of diamonds. The cards at bucket 1 is equal to new card 3 of diamonds.
What's up, it's a 4 different.
4 different suits. Okay, okay, but you were going to say it on the card side, right?
Yeah.
So we have 2 through 10,
Right.
and then we have Jack, Queen, King, Ace. Okay, so we have those of each of the 4 suits. So I can create maybe an array of suits, an array of cards. So I'm going to say this. I'm going to say private
Divide suit and value.
suits is equal to. Okay, now we're actually, and this guy is going to be a string array suits. We're going to do a array literal. I'm not sure if I've shown you these yet. It's effectively what if we created an array suits that was a new string array of size 4, and then we said suits at bucket 0 is equal to, hearts or the H, that kind of thing. So we say what, 8s, diamonds, clubs, spades. This is 1, 2, 3. What's this guy upset about? Oh, it's not private here. Sorry. So I'll create a string array called suits, capable of holding 4 strings, and I'll go ahead and fill it up with 4 strings. I can actually accomplish the exact same thing. String array, we'll call this guy suits 2 as you can, but I don't think that would really help us because they're not all the same length. I think you'll see once I write it, but you could do it, but I don't think it really benefits us in any way, other than just maybe making things a little bit more confusing.
There should be in 4 places. It should be in 4 places.
Oh, let's read this. That other syntax is Python. All right, so this is saying here is an array literal, HDCS. So suits 2 will be equal to the same thing as suits is equal to. Okay, this was a little bit easier to write. So I'll go ahead and name this guy suits. We'll delete that. So we'll say suits there. Then we're going to have string array, display names. And this guy is going to be equal to a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. So 13. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9, that's 10. That's jack, queen, king, ace. Well, I need values too. So I'm going to have a third one. But values is going to have the exact same number of things in it as this, right?
I thought these were their values, not this one.
Well, no, because the value of 2 will be 2, the value of 3 will be 3, value of 4 will be 4, value of jack will be 10, the value of queen will be 10, the value of king will be 10, the value of A, that's going to be your special case for your homework, but why don't we say 11 for right now, for this version of it. Okay, so now we'll have a string array. Actually, this guy's going to be an int array called values. All right, he's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, 10, 11. So we had a 10 here, a 10 here, a 10 here, and 10 here. So 4 10s and then an 11. That make sense? Yeah, well, for right now, I'm going to give you a deck filled up with, you're going to have to then apply that to the game of blackjack. Because we don't have a way of holding two different values. We have a way of holding one value. So you'll have to treat, there's only one card that's a special case. That's the ace. So that'll be part of what you have to figure out for your homework. All right, so for each of these suits, I want to create a card with each of these display names and values. All right, and I know I want to have 52 total cards. I know I want to put the first card at bucket 0, second card at bucket 1, bucket 2, all the way up to bucket 51. So I'm going to say int pos is equal to 0. That's the position of where I'm going to put the first card. Now I want to create a series of loops that will take me through all the suits, and for each suit, through all the display names and values. So I'm going to say for int I is equal to 0, I is less than suits.length, I plus plus. So that says for each suit, do something. Now I want to go through, I could either choose display names or values because they both have the exact same number of things in them, right? They're related to each other. So I'll say for int j is equal to 0, j is less than display names dot length j plus plus. Okay, like that. Now what I want to do is I want to put inside of the cards at bucket pos a new card built with suits at bucket I. Actually, what goes first in card? Display name, so it would be display name at bucket J, suits at bucket I, and values at bucket J. So we'll say this dot the cards at bucket pos is equal to a new card with display names at bucket J, suits at bucket I, and values at bucket J. And I'm going to say pos plus plus. So I make sure I put my next card at bucket 1, then bucket 2, then bucket 3, then bucket 4. Okay, so I'll start off with hearts, and this will build all of my hearts. The 2 of hearts, the 3 of hearts, the 4 of hearts, the 5 of hearts, the 6 of hearts, the 7 of hearts, so on and so forth. Because while I'm in this loop, suits at bucket I is not changing. Suits at bucket I, the first time is suits at bucket 0. Through here, I'm going through this 13 times while I is still 0. Then I fall out of that, I becomes 1. Then I go through 13 times while I is 1. Then 13 times while I is 2. Then 13 times while I is 3. Make sense how that's working? Yeah, because it didn't matter whether I said display names.length or values.length here, because this guy and this guy both have the identical number of elements in them. Bucket 0 of display names is the name. Bucket 0 of values is the value for that name. Yeah, so these guys literally match. I mean, even though this guy seems shorter because I don't have the double quotes, there's 13 values in here. There's 13 values in here. So they're the same. So bucket J of either of them references a meaning. This guy is the display name. This guy is the value associated with that display name. Okay? So my J is for that count. So this guy could be either display names.length or values.length. Either one is acceptable. All right, but make sure you do your pos plus plus here so it kicks it forward so I fill in the next card. All right, so that should fill up the deck. Now, what I want to do is we're going to have a public void display for the deck. We probably want to display all the cards in the deck. Now, since the deck is currently not shuffled, they're going to look very, very ordered, right? So I'll say for int I is equal to 0, I is less than this dot the cards dot length, I plus plus, and then we'll go ahead and say this dot the cards at bucket I. What kind of animal does that boil down to? So this dot the cards at, oh, actually, you might be right. If I were to display that, it would display a memory address. And that memory address would point to what kind of object? That's the real question I'm asking. What kind of object does this guy ultimately boil down to? He's a card. What lives inside of my variable called the cards? A collection of cards. So the cards at bucket I will be a single card. I can then tell that single card to display himself. So this loop says, go through all the cards in the cards, and for each one of those, tell that particular card to display himself. And we wrote display in cards, which prints it out like this. Make sense? All right, so if you wanted to get the full feature, you can maybe do something like this dot value concatenated with, we could throw his little value there in parentheses, just to kind of fully display the card, if you will. All right, so we'll go back out here to driver now, and instead of creating an individual car, we'll create a deck D is equal to a new deck, and that's going to go ahead and do all the work of filling up that deck with all the cards. And I should be able to say D dot display, and there's all my cards. So there's my 2 of hearts, 6 of hearts, 10 of hearts, jack, king, queen, king, ace of hearts, then diamonds, then clubs, then spades. That makes sense? Okay. Now, we want to shuffle those. How do we do that? Well, I already showed you, right? Just like we. Do I actually have to write the algorithm for shuffling, or can I just let you guys do that? How do you shuffle these?
Get a random number with the
Right.
152.
Okay, so probably our random numbers thingy would be helpful. Okay.
Unique random numbers.
Does it have to be unique? You want it to be.
Because we are using those for indexes.
Well, it definitely has to be values between 0 and 51, right? All right. So let's keep working with me on this. So you want to generate a random number. So I'll generate one random number between 0 and 51. Okay. What am I going to do with that?
You might declare a new array with size 52 and a new array index 1. You might have to assign the value of the cards randomly to the index between 1 and 52.
So create a temporary and then pick random numbers, which you want to do, and fill it in the temporary.
Okay. That's an extraordinarily bad idea. If I handed you a deck of cards and I told you to shuffle it. Now, if we moved past the idea of all the weird, all that stuff, what are you actually doing? What's a single shuffle move that you might make? Might you take one card out and put it somewhere else into the deck in just a random place? Then take another card out, put it into another. In fact, isn't that like a way some people shuffle? They just kind of spread all the cards out and then they kind of squish them all back together and they all slide in at different places and that thing, right? And then the people who are good at shuffling, isn't that when they split it in half and then they're folding it in there, and the cards are kind of laying in each other, right? And sometimes you're skipping 2, sometimes you're skipping 3, whatever it is, but you do that 3 or 4 or 5 times. You figure it's pretty shuffled, correct? So why can't I pick 2 values from my deck? Just pick 2 numbers between 0 and 51, and just swap those guys. And do that 500 times. Now, I don't want to pick the cards. I want to say, here's my 52 cards. I'm going to take this guy, I'm going to take this guy, and I'm going to make them change places.
So it would be like position bucket 2 and bucket 5 switch.
Yep.
So we might have to change those positions as well every time we shuffle.
Yeah, generate new numbers. Okay, I swapped those guys, so now we'll generate 2 more numbers. So this guy and this guy. Then this guy and this guy. Do that 500 times. What's the worst that happens? I decide I'm going to swap this guy with this guy. Didn't hurt anything. I wasted the run through there, right? Okay, but it didn't actually hurt anything. So let's go into our deck, and we'll teach this guy how to shuffle. And we're going to need our random number generator here, which is coming from java.util. So we'll go ahead and bring that guy in. So now I need to generate a number between 0 and the length of the cards. In fact, I need 2 numbers, right? So I'm going to have int pos1, int pos2. And then I'm going to need not a temp array, but a temp card for doing my swap. Because if I have these 2 cards here, if I take this guy and I overwrite this guy, I've lost this guy. So really what I need to do is I need to take this guy, put him over here in temp. Then I can put this guy over this guy, then I can take temp and put him here. Make sense? So we'll have card temp. And then let's say we're going to do this, let's say 500 times. So we're going to do something 500 times, and we decide that's not enough. We can just add numbers to this, right? So we're going to do something 500 times. So what's the something we're going to do? Well, we're going to set pos1 to some number between 0 and 51. We're going to set pos2 equal to some number between 0 and 51. Then we're going to swap the position of pos1 and pos2 in the array using temp as my helper. And then we're going to do that again 500 times. So pos1 is equal to r dot next int, and there's a version of this for bound that will give me a number between 0 and whatever bound I give it, not inclusive. So this will be this dot the cards dot length. So that'll give me 0 to 51, because the length is 52. And then I'll do the same thing for pos2. Ask him for another random number between 0 and 51. Then I'll go ahead and say temp is equal to this dot the cards at bucket pos1. Then this dot the cards at bucket pos1 is equal to this dot the cards at bucket pos2. Then this dot the cards at bucket pos2 is equal to temp. That does the swap. Do that 500 times.
So in loops, it really matters the order.
Tell me more about.
Like right now, you had to put the card in temp and then swap pos1 and pos2.
The order here it was important, because before we overwrote bucket pos1 with bucket pos2, we had to preserve bucket pos1. So this has less to do with the order is important in all for loops. It's in this specific for loop because of what we're doing in here. We had to preserve the value that lived in bucket pos1 before we overwrote it. That way we could use it to overwrite bucket pause 2 when we were ready.
If we didn't, we would just lose.
Yeah, you would duplicate pause 2. Pause 2 would exist twice.
Oh.
Yeah, and you would have lost whatever was at pause 1. So you get some extras of some cards and you'd be missing some other guys. Yeah, we want to keep all the cards, right? All right, so that's shuffle. So now I should be able to come into, so we already saw it display in order, correct? So now I'm going to go ahead, I'm going to say D dot shuffle, and then tell it to display itself again, and we'll see now it's fairly jumbled up. Make sense? Now, if we decide it's not jumbled up enough, we can come in here and we can, do this more times. We can do it 50,000 times. It'll probably feel like it ran the same speed. So there's 50,000 swaps. Whatever. A fun thing I did one time, I don't remember how long it took, but you can, I'm trying to think how many times it took. How many times did we have to shuffle the deck before the original deck before the shuffled deck became the original deck? Just by chance. See what I'm saying?
Number of times that he was saying.
So, I have 52 cards that came in the deck, and originally we saw they were very ordered, correct? How many times do I have to do this random shuffle, this swapping 2 places, before the shuffled deck is the original deck? I actually shuffled it back to its normal order, just by pure chance. You see what I'm saying? Well, I mean, it's also relative to how random your random number generator is. It was a lot. But it was kind of a fun thing to write. It was like, well, we're just going to keep shuffling until it's back. Right? It's a similar thing is when you think about it, if you want to think about it in a simpler case, how many times do we have to generate a random number before you generate a 0? Right? Because if we do normal random numbers, normal random number generator, it gives us between -2 billion and +2 billion. Right? And each one should be mutually exclusive. So each time we roll the dice, if you will, we should get a number between 0 and 4 billion. Okay? So we should have a 1 in 4 billion chance of getting a 0. So roughly 4 billion times is how many times it would take to get a 0. So it's kind of interesting, just chance like that, because there's actually a whole research area in computer science that deals with true sources of randomness, and these are called pseudo-random number generators. They're considered decent sources of random values, but not great sources of random values. Go ahead.
We just assigned an object to temporary object. Can we do that in any other language? Somewhere I saw that we can't do that we need to do member to member assignment.
You're talking about this guy?
Yeah.
What I did right here?
Yeah.
You can do that in every language. I mean, this guy here is not an array. That's a card.
Yeah, I know that. But somewhere I saw that I can't do that, but I need to assign member to member in the object. Like this cost dot string. This card dot name value to this card dot name value. We might have to assign every member of one object to every member of other object. You can't just assign an object to an object.
Well, if you assign an object to an object, they both still point to the same object.
Modify, create the temporary as a new object.
Well, if you said temp is equal to new card, let's do ace of clubs with value 11. Like that. So temp currently has a memory address that you just overwrote right there. So this guy was a waste of time at that point. So now, after this line right here, temp holds the same memory address as this dot the cards at bucket pos 1 holds. So you have two separate variables pointing to the same place in memory. Does that make sense? Yeah, I mean, maybe something you're talking about is, what if I have two cards and I want to duplicate this card? All right, so I have an ace of spades, okay, and I want two aces of spades. Okay, I don't want two different ways of talking about that single ace of spades. I actually want two of them. Okay, I want to duplicate the card. So in real life, what do we need to do? We got to go get another deck of cards, pull the ace of spades out of there. Now I have two aces of spades. They're the same card, but they live in different places. One's in my left hand, one's in my right hand. Different memory addresses, right? If I wanted to do that here, I'd have to clone it.
Can we do the same with arrays?
You do the same with arrays. Well, I mean, sure, you can duplicate the contents of the array.
I mean, can I just declare an array and point the other array to the
Yeah, anything is a memory address. I mean, that kind of goes back to what we originally talked about with Java, where a lot of textbooks say pointers don't exist in Java, where everything's a pointer in Java, right? For instance, if I came, so I have this array called the cards, right? If I came down here and I said card array temp is equal to this dot the cards. Now, temp and the cards both point to my single deck of cards. This is the actual array in memory. And I have two different variables that point to it. That make sense? Yeah, I mean, an array and object, they're all the same. It's just a memory address. Okay, it's what lives at that memory address that might be different. You know, I can give the address to a McDonald's. What lives at that address is a McDonald's. I can give you the address to my house. Well, that's not a McDonald's at my house. It's just a house. Okay, but they're both addresses. They just lead to different things, different types of animals.
So all we are doing is creating a new reference, but we are not actually creating new memory space.
Well, yeah, but so let's take away this guy right here. So right here, I am preserving the memory address in temp that is currently being pointed to by the cards at bucket pos 1. Why do I have to do that? Because on this line, I'm overwriting the cards at bucket pos 1 with a new memory address. Had I not preserved it, that card that lived up in memory there is now gone. I had no way of getting back to him, and automatic garbage collection is going to clean it up. So that's why I said, okay, well, before I overwrote this guy, I'm going to point at him with this other variable. Okay, that way I can change this value here that used to point to him. Now he points someplace else, but I still have access to this guy.
So can I call temp as pointer to an object?
I mean, that is what it is. I mean, temp is a variable of type card. Card is an object type, so temp will always hold a memory address that is a pointer to the actual card in memory.
So does it mean Java is allowing us to declare pointers?
Yeah.
So we do have syntax to
Not syntax for declaring pointers, because you have no way of saying, is this an address or is this the value at that address? That's what we don't have in Java. We don't have a specific syntax to say, I want the address or I want the value at that address. Java makes the decision based on what you write. So if I say temp.display, Java knows that when I say temp in that case, I'm talking about the actual card that lives at that memory address. But if I just say print temp, Java says, oh, you must mean the address. Java figures out what you meant based on the context in which you're using it. Where in a language like C++, if I say, if in C++, the syntax would be card pointer temp. Then if I were to say temp, that is a memory address. If I were to say star temp, that says give me the value at that memory address. Okay, that's having a specific syntax for manipulating pointers. Java doesn't do that. Java figures out what you meant by how you used it. Okay, so in Java, everything is a pointer, but we no longer control how that pointer is perceived. We get memory addresses when we try to print them, and we get the actual thing when we try to use it. And Java totally makes that decision, which most of the time is fine, but some of the time it's not, is kind of the idea. All right, so there is our shuffle. All right, questions about that? Am I doing it 50,000 times now? What am I doing? Yeah, we'll cut that down to 5,000. We'll meet in the pseudo middle. All right, so questions about the homework? Everybody knows what they need to accomplish to do the homework, and this is a good starting point. So what I'll do is I'll go ahead, just to kind of show you the normal workflow. I'll go ahead and I'll do git add dot. Again, this is my repository, and if I do git status, you'll see that only certain files are new. So I've modified driver.java since the last time I did this, okay, because now I'm talking about a deck of cards. I've added deck and I've added card. So then I'll do a git commit -m, m is the message, added stuff for blackjack starter. Okay, so now I committed the local repository. Finally, I need to push the other one, so I'll do git push -u origin master. So I want to push uploading to that position, the thing at GitHub origin, my local repository called master. So that guy's done. I come back in here and I go to my GitHub. Oh, that's a different class. Here is this guy right here. So now there is my deck and my card. And that's the added stuff for blackjack starter classes. Make sense? All right. Questions, comments, concerns, bribes? All right. I will see everybody next Wednesday. I did not give you the writing assignment. What would the writing assignment have been? Let's see.
It doesn't matter now. The class is already underway.
Modern programming, object-oriented programming and modern programming solutions. How does it compare to procedural programming? Oh, that would have been a good paper too. Maybe I'll have to give you an extra hard paper for that 2-week.